Good morning. Welcome to Computer Science 221. We're going to continue on in Chapter 5. We're going to learn just a couple of more commands that exist in the LC3. And you'll notice I've also got the online simulator up here. I've made an executive decision that I think this is going to be the software that we're going to use from now on. The reason for that is this works on an Apple, this works on a Windows machine, it works on either one. It has all the features that we need. I want you to note down here at the bottom, there are a couple of features here that we're going to find useful here. This thing says assemble, this thing over here says raw, and actually I'd like to give you a demonstration of that right now. Let's try, I want to write a very, very simple program here. And I'm going to be switching back and forth between keyboard and tablet. I hope you'll be sympathetic as I'm moving things around. So let's suppose I want to load into R0 a number that is at 3010. And I want to load into R1 a number that's at 3011. I want to let R2 get R0 plus R1, and then I want to store R2 at 3012. And let's pretend that this statement over here is at 3000, and we want this statement over here at 3001. We want this statement over here at 3002, and we want this statement over here at 3003. Okay? So I need to look in the back of my LC3, and to do this statement over here, this is at location 3000, and I'm doing a load, which is a 0010, and I am loading into the destination 0, and then I have to give a PC offset of 9. Well, if I'm at location 3000, the PC is at 3001, and I want to have a number at 3010. So from 3001 to 3010, that's an offset of 15, or F. So that's a 0, 1, 2, 3, 4, 1, 2, 3, 4. And now I'm going to come over here at 3001. And now I want to load into R1, which is at 3011. So again, that's going to be a load. And I'm putting it into register 1. And at this point, the PC is at 3002. But I'm going up to 3011. Well, remember, this is 17, 16, 15. That's also an F. Oh, that makes life easy. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to come over here to 3002, and I want to add them. So add is 0001, and the destination register is R2, so that's 010. I'm adding R0, so that's 000. Then remember, I have to put 3 zeros here, and now it's R1, 001. Okay, and finally at 3003, I want to do a store. So a store has an opcode of 0011, and I want to store R2, so that's a 010. And let's see, I want to store it at 3012, and the PC's at 3004. So if I'm 3004, and I'm getting up to 3012, remember 12 is really, that's in hex, so that's 18 minus 4 is 14. So 14 would be in E, like that. And let's see, so in E is 1110, okay? And then I have 1, 1, 2, 3, 4. So there's my program there. I have to remember at location 3010, I need to put in some number. I don't know what number I want to put in here. Let's make something up. 1, 2, 3, 5. And over here at 3011, I'm going to put in 1, 2, 3, F. So let's see, F is 15 plus 5 is 20. So 20 is a 16 plus a 4. That's what we expect to see in location 3012. Okay, so far everything's pretty standard, but I want to show you a couple of tricks here now about what I can do. Okay, so I'm going to try and keep this up on the screen at the same time that I have this up on the screen. I'm going to move this over a little bit. Actually, what it is that I want you to note is I want you to notice way down here at the bottom of the screen, there is this button here that's called RAW. And what RAW does, it opens up a screen. Notice I see a bunch of zeros and ones in there. Now, I was doing some practice before I did the video here. Let me get rid of those. Okay, now I can do one of two things here, and we'll do this twice just for fun. I could enter in these binary numbers right here. So if I wanted to, I come over here. I guess I need to do this so that everything remains up on the screen. And that's going to be a little tricky, but I can do it. So notice here at 3000, I've got 0010, and then 000, and then another 0, 1, 2, 3, 4, 1, 2, 3, 4. And that's it. Location 3000, 3001 is 0010, 0010, 1, 2, 3, 4, 1, 2, 3, 4. I'm just copying this. At 3002, I see 1, 2, 3, 1, then 0, 1, 0, 0, 1, 2, 3, 4, 1, 2, 3, 1. That's 3002. 3003 is 0, 0, 1, 1, 0, 1, 0, 1, 2, 3, 4, 5, 1, 2, 3, 4. So here is my code right here. But here's another trick, and here's something that I have to do. Here's my code, and what I need to do, the very first line here, is I need to tell this thing where I want it to load this code. Well, I want it to load it at 3000. So the very first number that you see up that I'm going to type in here, okay, it's going to be a 0011, that's a 3. 1, 2, 3, 4, 0, 1, 2, 3, 4, that's a 0, 1, 2, 3, 4, that's a 0. So this very first line here is an address, okay, and that's where in memory I want this to start. So I'm going to come over here and I'm going to say process, and it says to me, awesome. See it right there, I'm awesome and I'm very happy about that. And I'm going to come over here and it says load into simulator. So I'm going to load it into the simulator, and now I'm going to come back over here and notice here is the code that I actually put in. Now we loaded it in binary, but I think if you sit here and you look at this right here, this sort of looks like what we want to do. Now the problem I have is if I come over here to hex 3010, I don't have any data in there. Now, we all know I could come in here and I could just type them in. But I want to show you another trick. I'm going to come over here and I am going to go to RAW. And now I'm going to get rid of all this. Now remember, this is, and I'm going to put spaces in there and take it out. That's 3. That's like that. That's 3, 0, 0, 0. I want to make this a 1. So now that's at 3010. And I'm going to do an experiment. I don't know if it's going to like this or not, but I'm going to put some code in here. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 1, 0, 1. So notice that that's a 5. And then I'm going to come over here and I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And then over here I said I wanted an F, 1, 2, 3, 4. And let's see if it lets me process with the spaces in there. Ooh, it was okay with the spaces. Makes it easier to read. And I'm going to load that into the simulator. So notice what happened over here is at location 310, there's a 5. At location 311, there's a 15. Let's go back to 3000. Notice at 3000, my program is still there. So now I'm going to come over here and I'm going to change the PC to 3000. And I'm going to come over here and I'm going to step. And I'm going to step. And notice, by the way, I've read the 5 into register R0. I've read 15 into R1. I'm going to do a step. Okay. Step means I added them together into R2. Notice that I've got a 1, 4, which is 20. And now I'm going to start at 3012. I do a step. And now to verify that it works, I'm going to come back here and type in a 12. And notice at 12, I've got the number there. So the point that I'm trying to make is that we can use this feature down here for raw. We could have also entered these in hex if we wanted to. Either one of these would work. And once it's in there, we hit the word process. The thing you have to remember is it always must be the case that the very first line is actually the address of where you want all the stuff that follows to go. That's very, very important. So we'll actually be writing our programs using this tool as well. Okay, we have a couple of more instructions to learn about. And this is in the section of the book that talks about branching, okay, or about moving the flow of execution. Now, we're familiar with this branch. And we know that with the branch, there are these 3 flags, and it's a negative, and it's a 0, and it's a positive. So we can do a conditional branch. We also, in other words, if we did this, we would look at the state of the flags. If the positive flag is set, branch on a positive. We have a, let's see, it's 4 plus 3 is 7. We have 9 bits over here. So we have a 9-bit signed offset that we can go to, and we know that that's plus or minus 512 bytes. We know that if we did a branch, and we set all of these, that is an unconditional branch. Again, we're limited to 512. That's if all 3 of these are set. Well, what happens if I wanted branch more than 512? Well, it turns out that there is a jump instruction. And let's see, that is a JMP that has an opcode of 1100. And basically, the way that this works is it looks like the following. We've got the 1100. There are 3 zeros over here, and then we use 3 bits to specify a base register. And then after the base register, we've got all zeros. So we know that a register is 16 bits, so what happens is if the base register is going to have some 16-bit address, okay, and what happens is we would basically load the PC, we just get the contents of the base register, and we would jump to that. Well, let's think about why you might want to do this, okay? First of all, we realize that this could be restrictive over here, but let's imagine here is computer memory, and let's suppose over here at 3000, Let's suppose this is your program. And it runs down to here. And let's suppose over here at location 4000 is some other program. I'm just going to say other program. Like that. And let's suppose that this program over here does some output to the screen. And let's suppose that this program over here also does output to the screen. Now we're going to learn in a little bit that writing output to the screen is actually a fairly involved process. It's pretty complicated, and in fact we as programmers very rarely will write the actual code to do the output to the screen. We just say print or system.out.println or something like that, and it magically appears on the screen. Well, it turns out that somebody else has written the code to output to the screen. Who's written it? Probably some guy working at Microsoft. And we're going to see this later on. This might be, we might store that in memory over here, maybe at location 8000. And over here, at some point I want to do some output to the screen. So when I'm at this point, I want to jump over here. And likewise, this person wants to do some output to the screen. So they, at this point, they want to jump over here and start executing this code. So again, there are all sorts of issues here that I'm not addressing, but the point is that this from here to here is more than 512 bytes, and that's when we would use a jump to a base register. So let's consider what the code for this might actually look like. So let's suppose at hex 3010, I want to jump to 8000. Well, how would I do that? Well, I think what I might do is something like the following. Suppose, so at 3010, I want to do a jump. And remember, this is going to be a 1100, and there's going to be a 000, so that's a 000. A base register, why don't we let the base register be register 3? So it's going to be 011. And then these are all zeros. 1, 2, 3, 4, 5, 6. R3. Okay. So that wants to be the jump. Okay. So what I need to do over here, I'm going to say at 300F, what I need to do in this statement here is I need to get 8000 into R3. So here's 3010. Well, how about if I do this? 3011. Let's put an 8000 there. So an 8000 is going to be 1000. And then these are all zeros. And then why don't I over here at the instruction right before this should probably be a load. Well, a load I am going to look up is 0010, and I want to load it into R3 011. Now remember, what I'm going to be doing is the PC will be at 3010. This is confusing. These are the same one. So I need an offset of just 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this line right here is going to load up R3. This is going to do the jump. Here's where I put the address. Let's just watch this in action. So I'm going to come over here, and I am going to do a raw, and I'm going to come over here, and let's see if I can get this all on one screen. Yes, it looks like I can. Whoops, maybe it doesn't mean I can. I'm going to do this. Yes, that'll do it now. And I need to get my keyboard here. So the first thing I want is the address where this all starts. And this is going to start at 300F. And what I want at 300F is this is going to be my load instruction. So it's going to be 0010, and then it's going to be 0110, 1, 2, 3, 4, 1, 2, 3, 1. Here's my jump instruction right over here. My jump instruction is 1100, 0000, 1100, 0000. And then what I need to put here is this is 1000, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So what I'm going to do is I'm going to process this. Again, it tells me I'm awesome, but we knew this. We load this into the simulator, and I want to start at 300F. So I come over here. So notice at 300F, it is saying load R3 with 3011, and then I'm doing this jump. And what I'm going to do, notice that the PC is already at 300F. So basically, to prove that this works, I'm going to step, and I want you to see what happens to the program counter. So here, the program counter just went to 3010, but now I'm going to execute the jump instruction. And I'm going to guess, you'll see over here, the next place it's going to be is at hex 8000. And you can see the PC is now at 8000, and that's indicated right over here. So that's how the jump instruction works. Okay, it's time to talk about traps. Traps and trap vectors. Okay, so as I indicated to you a few minutes ago, these are sometimes what are called system calls. That's what I'll call them. I don't think your author does. Input and output are usually pretty complicated things, and it is very infrequent that you and I actually ever write the codes to do the input-output. We just use a scanner class to read stuff in. We use a system.out.println to print stuff out. But there's a lot of complicated stuff that's going on under the hood. And the mechanism of what's going on here will be explained later in the class, but basically what is going on is a lot of this complicated code gets read into memory someplace. So maybe someplace here in memory, here is the code for input, and maybe over here someplace, here's the code for output. And here's our program up here, our program. And at various points we need to come over here and we need to execute this. Or at other times we need to come over here and execute that. And there were a couple of problems with this. Like how we saw before that we can do that by using a jump. We could just load the beginning address of input into a register here and then do a jump on that register. But you have another problem. And the other problem is that when I boot up the computer, these things may actually get loaded into different places in memory. So how do I know where to jump? And the answer is I don't. We'll get into the specifics of how that problem is answered later on. But right now, what I want to say is that most computers, in fact all computers, when you buy them, they will come with a technical reference manual, and someplace in there they will have a list of traps. And again, I find that kind of a funny name. I would say a list of system calls. And they'll list them, and they'll have numbers. So they might say trap number 1 does this, trap number 2 does that, and depending upon how complicated the system is, there could be quite a few of these, 100 or 200, and they do various things here that may have to do with input or output or other things that are going on. Now, in our nice simple computer here, the LC3, you need to look in Appendix A2. For a list of traps. Now, let me tell you a couple of very simple ones. Trap X hex 23, what that does is that actually gets input from the keyboard. And the question is what does it do with it? Well, it puts the ASCII code, it puts the scan code into R0. And we'll see this in a moment. Likewise, there's another trap called Trap 21, and that is output to monitor screen. And the question is where does it get the character that outputs to the monitor screen? And it gets it from R0. Now the thing you need to realize, I'm doing character input here. Character input is 8 bits, and both of these are 16-bit registers. What's going on? Well, the leftmost bits are all zeros, so I'm only using the right 8 most bits. And the other one that you should know about that's an interesting one, and we're going to start to use this one right over here, this terminates a program. And we're going to start to use that one quite a bit. Okay, so with that in mind, let's try some of these out. So first of all, so trap takes the form of this. Here's the opcode. And then what happens, I'm going to put a T, 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 and then I'll call it V, 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 trap vector. So for example, remember we said that hex 23 was getting input from the keyboard. So if I went 1, 1, 1, 1, 0, 0, 0, 0, and then I put a 2 in here for the T, so 2 would be 0, 0, 1, 0, and then a 3, it would be 0, 0, 1, 1. This is going to get input from the keyboard. Let's just see that very quickly. So that's F0, 2, 3. So I'm going to come over here to the simulator, and I am going to come over here to memory location 3000. And at memory location 3000, I am going to put in F023. F023. And notice what it does is it the assembler here, the machine, it's kind of smart, and it says, oh, this person's getting input. We call it in. Now what I need to do here, I'm going to come over here and I'm going to clear all the registers. I'm going to come over here. The PC is set to 3000. I'm going to come over here. Now here's the console screen. I'm going to clear the input buffer, clear the output buffer. Notice the console is nice and clean now. And what I'm going to do is, let me do this actually, because I want to put another trap right over here. And that's halt, okay? Remember we said this is what you do when you want to run the program. Now previously, we've stepped, and here we're not going to want to step, and I'll show you why in a second. Here, I just want to do a run. But the thing I want you to notice is notice that all of the registers up here have zeros in them, and I'm going to hit run, And what's going on here, I don't know if you just saw it, but it just came over here and it said input a character. So I'm going to click down here on this window and I'm going to hit a capital A. And notice that the processor has stopped. But what I want you to note is, where is my capital A? I don't see it. This is not good. I am going to run this again. I am not happy. I'm going to come over here and hit unhalt, clear all the registers. Okay, it's got a 3000 into it. And what I am going to do, I'm going to set a breakpoint here at halt. So now what I'm going to do is I'm going to say run. First I'm going to clear everything. I'm going to say run. It's asking me to input a character. And I do capital A. Ah, there we go. There's my A right over there, 41. What I've done here, you'll notice over here, I've set a breakpoint. And here I can clear it. Here I can set it. What that means is that when I set the PC over here to 3000, and I say OK, and then I say run, it's going to run until I hit the breakpoint. I'm going to clear all the registers again. I want you to watch this. So I'm going to hit a run. First, let me clear everything down here. I'm going to hit run. This time I'm going to type in a B. It stopped. Notice over here, I've got ASCII 42, which is a letter, is B. Let me try something else here. Now this was in. I'm going to change this. We said that output to the monitor is a 21. And then I'm going to come over here. So notice what the assembler's telling me, what the machine's telling me. This is going to get a character. This is going to output a character. What I'm going to do, I'm going to come over here. I'm going to set the PC back to 3000. Okay, I'm going to come over here and set a breakpoint. I'm going to come over here and clear the console. And I'm going to hit a run. And now it's asking me to input a character. And watch what happens. I'm going to type the letter M. Okay. Oh, I have a problem here because I had a breakpoint there. Clear this breakpoint. Please excuse me. I'm going to start this all over again. There's no breakpoint there. There's no breakpoint there. There is a breakpoint there. So I am going to clear everything. And I am going to run. And I'm going to type in the letter M. I have to click on the window here. And notice what happened. Here's the one that I typed. Here's the echo right here. Okay? Let's try another experiment. We know that when I come over here, okay, that what this did is that this put a character in here. I want to change this now. And what I'm going to say here, let me get to a screen here, okay, and I'm going to say, suppose I type in A. Suppose I type an A. Now when I type in A, in R0, I'm going to get a hex 0041, a 65. Then what I want to do is I'm going to say let R0 get R0 plus 2. So that's going to make it a 43. And I'm going to type it out on the screen. And when I type it out on the screen, I should see a C. So we know this over here, this is going to be, let's see, add is 0, 0, 0, 1, and I'm going to do it to 0 and 0, and I want a literal, and I'm going to make this 1, 2, 3, 4, 5. So that's a 1, that's a 0, 1, 2, 3, 4, 1, 2, that's a 2, 2. So I'm going to come over here. I'm going to change this a little bit. I'm going to come over here and make this 1022. Okay, and over here I'm going to make this a hex F0, and I want to do output, so that's going to be a 21. And then over here I'm going to do a hex F025. That didn't take. F025. Halt. Okay, let's clear all the clear this breakpoint. Let's set a breakpoint. Okay, let's set this back to 3000. Okay, let's clear the output screen and watch what's going to happen. So I'm going to run. It's asking me to input a character. So I'm going to come over here and I'm going to input a D. And notice what it did is it added 2 to D, E, F, and it output it there. Kind of cool, huh? Well, let's try something a little more complicated here. Here's what I want to do. I want to go into memory, and let's say at 3010, I want to put in a hex 0042, and then 3011, I'm going to put in a hex 0049, and then at 3012, I'm going to put in a hex 004C, and at 3013, I'm going to put in a hex 004C. Now you might be wondering why I'm doing that, and the reason is because that's a B, and that's an L, I, L, L. And then what I'm going to do, 3014. I'm going to put in here a 0000. Okay? And what I'd like to do is I would like to print Bill out on the screen. Now, basically, what I need to do is I need a register. Let's think about this a little bit. I'm going to need a register. Remember, R0 is where I have to put these things into to print them out. So I think what I want to do is I want to do some register addressing, and I want to do something like the following. I'm going to let R1 be, I want this to have a 3010 into it. Then what I'm going to want to do is I'm going to want to do an LDR, okay, R0, from whatever, I want to load R0 with memory of R1. And the thing is I've got this 0 over here, and that's what's called a sentinel value. That represents the end of what I want to print. So what I want to do here is after this, I want to come down here and I want to ask, does R0 equal 0? Is the 0 flag set? And if the answer is yes, I want to get out of here. And if the answer is no, I want to print to R0. Okay, I want to add one to R1. And then what I want to do is I want to come back to here. So this would be yes. This would be no. Okay, this is the program I want to write. So let's think about what I need to do here. So at 3000, I am going to issue a load command. And again, I need to go to the back of my book, and the load command is a 0010. And let's see, I want to get a 3010 in there, so it's going to be load into my destination register 001. And here's the thing that's kind of difficult. I want to get a 3010 in there. What do I want to do? Okay, set a load. No, I made a mistake already. I want to do a load effective address. Okay, and I need my thing to fix this up. I don't even know where it is, my eraser. Anybody see my eraser? Don't save. I don't see my eraser anywhere. That doesn't belong here. Ah, where's my eraser? Images, font. I don't see it at all. Okay. It's easiest just to do this. At 3000, I need to do a load effective address 1110 and load effective address into my destination register 001. When I'm at 3000, I want to add the PC. I need an F over here. 3001 to 3010 is an F, so that's a 0, 1, 2, 3, 4, 1, 2, 3, 4. So that takes care of that. Now what I want to do is I want to do an LDR, and an LDR is a 0110. And my destination register is register 0, and my base register is register 1, and I have an offset of 0. So that's taking care of this over here. 3002 is going to be my branch on 0. So I want to do a branch, which is 0000 on a 0. And I want to branch to the end of the program. I don't know where that is yet. I need to figure that out. But otherwise, what I want to do over here is I want to call my trap to output a character. That's trap 23. So that's 1111 0000 23 0010 and a 3 0011. I want to add 1 to R1. Okay, so my add is 0001. I want to add it to R1, so that's going to be a 010. Whoops, that's a mistake. It's going to be a 001, 001, then it's going to be a 1, and it's going to be 1, 2, 3, 4, 5, and then at 3005, I want to come back over here to the load statement. The load register statement is over here. So at 3005, I am at 3006, and I want to go back to 3001. That means I want a -5. Well, 1, 2, 3, 4, 5. Let's see. It's 101. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to go 1, 1, 1, 1, 1, 1, 0, 1, 0, and add a 1 to it. That's what I need there. So over here, this is a branch unconditional, and a branch is 0, 0, 0, 0. Then it's a 1, 1, 1, and then it's to this number here. So it's 1, 1, 2, 3, 4, and then 1, 0, 1, 1. That's at 3005. So I want this to branch over here to 3006. Well, when I'm over here, the PC's at 3003, so I need the number 3 over here. 1, 2, 3, 4, 5, 6, 7. So I've got a lot going on here, but let's see if we can get this to work. Okay. First of all, I'm going to come over here to the simulator. And I'm going to come over here and I'm going to say raw. And what I want to do over here, I can do this in hex. So I want you to see how I do this. So I am going to say at 3010, I want to put in 0042, 0049, 004C, 004C, and then 0000. Okay, and let me move this over so you can see this all happening. So I'm going to come over here and I'm going to say process, and it says awesome, and I'm going to load it into the simulator. And when I come over here, okay, there's my BILL, and there is my terminator there, the 0. Now what I want to do is I'm going to come over here to raw, and I'm going to say it's 0011. Okay, so notice that is at 3000, and I'm going to start typing in the code that I see here. So the first one is 1110, 001, 0010, 0000, 1111. The next line is 0110, 1234. I hope I'm getting this right. 3002, 1234. 3003. 3004 is I'm not happy here. 001, 1, 1. Something's not right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Something is wrong here. This is 001, 001. That is an add. Register 1, 3, 6, 10. No, that's right. Something's wrong over here. 0001, 001, 001, 1, 0, 1, 2, 3, 1. That's correct now. Okay. And then I want to do my branch back 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 0, 1, 1. Okay, and I'm going to process that, and I'm going to load it into the simulator. And let's see, that's a load effective address. Here's my load register. Here is my branch on 0 to 3006. Otherwise, I do an in. No, that's not right. I want to do an out. So that shouldn't be a 23. That should be a 21. I do an out. Here we go. So this is going to be very exciting, folks. So what I'm going to do is I'm going to come over here at 3006, and I'm going to set a breakpoint. And I am going to come over here and clear the various screens. I'm going to clear all the registers. I've got 3000 in the PC, and I'm going to do run. And notice over here that nothing happened. So we need to do some debugging. There is something wrong over here in 3001. It says load R0. That is incorrect. 3001. That is 0. Let's take a look at 3001. If I come over here at 3001, this is a good debugging exercise for all of you folks over there. So that's a 6. 1, 2, 3, 4. That's a 0. 1, 2, 3, 4. 1, 1, 2, 3, 4. 1, 2, 3, 4. That's a 4. 0. So it should be 6040 with 3001. And it's not. We're off by a bit. That looks much better. So now I'm going to clear everything. I'm going to come over here. Everything looks good. Now I'm going to run it and see what happens. Maybe we should, no, I don't want to step through it. I'm going to run through it. Oh, and there is, I'm going to clear this breakpoint and I'm going to start again. And there we go. There is Bill right there.